Alright, so in this video we're doing a calculus problem where we're trying to compute the limit that we've got on the screen, and it's the limit as x goes to infinity of x multiplied by tangent of 1 over x. And so if we attempt to evaluate this right off the bat, we end up with one of the indeterminate forms, because we would have as x goes to infinity, x is also going to go to infinity. And we know that 1 over x goes to 0, which would give us infinity times the tangent of 0. So we get infinity times 0, and that's one of the indeterminate forms, which tells us that we may want to use L'Hopital's rule. Of course, in order to use L'Hopital's rule, we've somehow got to figure out how to write this expression as a quotient, and so we can do that. Take the limit as x goes to infinity, and if I multiply by x, that would be the same as dividing by 1 over x. And this still gives us indeterminate form, because the limit as x goes to infinity of 1 over x is 0, and we know that the tangent of 0 is 0. So this is still indeterminate form, 0 over 0. So I'm going to apply L'Hopital's rule, which says that we still take the limit as x goes to infinity. And I'm going to take the derivative of tangent 1 over x. Of course, the derivative of tangent is secant squared. And by the chain rule, I have to multiply by the derivative of 1 over x, which is negative 1 over x squared. So that's the derivative of my numerator. The derivative of the denominator, 1 over x, is, well, we just did that here. The derivative of 1 over x is negative 1 over x squared. So I was not using the quotient rule, using L'Hopital's rule, which says take the derivative of the numerator separately from the derivative of the denominator, and that if you apply the limit, it is an equivalent expression. So here we can cancel out our minus 1 over x squareds, and then we can evaluate this limit, because we can do secant squared and apply the limit as x goes to infinity, 1 over x, which of course we know is 0, secant squared of 0, and if we remember our basic trig identities, secant is the reciprocal of cosine. And cosine at 0 is 1, so we get 1 over 1, which is just 1, and that gets us the limit that we were after.